All right, hello everyone. Well, I wanted to run through this example of a flip-flop circuit with you in a more interactive way than just showing you a bunch of still pictures of one in action. So I've set it up here, and you can see that it involves two NOR gates that are linked together in kind of this unusual way. So because it involves NOR gates, I thought it might be good for us to just first be really clear about what it is a NOR gate does. So here's a NOR gate, and it's receiving 0 and 0 as its inputs, and that means that it will power up this bulb. A NOR gate only lets a current go through whenever it doesn't receive any input at all, or any current at all from either of its inputs. Okay, so you can see if I turn on one of these switches, the NOR gate's going to shut off. If I turn on both of them, or turn on only one, the NOR gate has no power. But when I turn off both of them, it powers back up. Okay, so with that out of the way, let's reason through what will happen when I click this upper switch right here in the flip-flop. Okay, so if I give this a 1 as a signal, this NOR gate is going to shut off. So right now it's currently giving power to this one, meaning that this is shut off. So if this one turns off, then this one will receive 0 as an input and 0 as an input, meaning that its output will travel to the light bulb and light it up. Its output will also feed back into this one, and it will keep it off. So let's see that happen. Okay, it lights up the bulb, and then the reason why this is significant is what happens if I keep trying to toggle on and off this switch. So watch what happens now. If I turn it off, the bulb is still lit. If I turn it back on, the bulb is still lit, and if I keep turning this on and off, however many times I want, nothing will happen. This bulb will remain lit up. So this is a way to save one bit of information. This is basically a memory cell that can remember that we have pressed this and turned it off in the past. So hitting this switch at all is like writing a 1 to memory. And then if that's true, I bet you can imagine what this switch will do. Well, let's reason through it. If I turn on this switch, it's going to give this power, which means that suddenly this will turn off its output, right? The bulb will no longer be lit, and it's going to turn off this input, meaning that this will turn on, and it will keep this thing off forever, no matter how many times I toggle this. So pressing this once, or pressing it any number of times, is like writing a 0 to memory right here. Our flip-flop is actually a very primitive memory register. It can remember that I've wanted a 1 to go into memory, or a 0 to go into memory. Okay, so we're actually going to give these two switches names. We're going to call them set and reset. So I can set memory with a 1, or I can reset memory to 0. So this type of flip-flop is called an SR flip-flop. Okay, and before I end the video, I just want to show you one more thing that I thought was kind of neat. Logic.ly also has a more advanced version of this flip-flop that we just made, the SR flip-flop. And here it is as an integrated circuit. Okay, and you can actually click on any one of these things, double-click on them, to see all of the logic gates that are inside. So if I do that, it's kind of overwhelming. Look at all of this mess. But basically the idea here is that this would be the clock signal, and this would be the set, and this would be the reset button, and then this would be the output light bulb, and this would be the exact opposite of the output light bulb. So let's get back out of there. And we're not going to get into the details of how that one is set up, but I just want to talk about it at a high level. And I want to try to just mention really quick what its purpose is. So ultimately, the idea here is that we won't just have one bit of memory, we'll have millions of bits of memory, right? We'll have gigabytes of memory. So it's just going to be a lot of these components, basically, that are all arranged in a nice orderly little grid. And the extra features of this type of flip-flop allows us to basically select which bit of memory we're going to write a 1 into or a 0 into. So you can think of this middle signal here as being an enable signal, which will be controlled by a clock signal eventually. Here's a clock, and logically you can tell it's just turning off and on, and you can even see this little square wave symbol here. So the idea is I connect the clock signal to this pin right here, and that's going to just say whether this bit of memory is allowed to write a 1 or write a 0 into it. It's like saying which one is active, when you could imagine that there might be, like I say, millions of these things side by side. Only one will get a clock signal pulsing to it at a time. Okay, and here I've just paused for a minute and I've hooked up all of the little components to it. So this is S for set, and this is R for reset, and then Q is the output. Right now you can see it's a 0. And this is just another pin for the opposite of Q, which is sometimes used and sometimes not used. But basically this works exactly the same way. I can click set, and after the clock gives it a pulse on and off, a 1 will be set to this memory. And then I can turn it off, and turn it back on, and turn it off, and turn it back on. And you can see there's no change. It remembers that I had a 1 go into it in the past. But then I can also reset, and then the bit of memory will have a 0 stored into it. Okay, and realistically, you wouldn't directly hook up your clock, right next to this bit of memory. Really, there would be something in between the clock signal and this bit of memory that was selecting, which one out of all of the millions of bits of memory you were going to enable the ability to write into it or not. And then this set and this reset actually wouldn't literally be right next to it, but they would be basically wired to all of your memory. And by choosing which memory to set a 1 into or set a 0 into, you have the ability to basically have a single point of control over storing information in your computer. Okay, so I think that's all I wanted to say for this video. Thank you for watching.